From Here to the Stars, a video series created by the Tennessee Valley Interstellar Workshop. The TVIW is a non-profit organization dedicated to thoroughly exploring the science and engineering that can eventually open up the reality of interstellar travel. I am your host, Stephen Euin Cobb. Our guest today is Dr. Louis Friedman. Louis Friedman holds a PhD in aeronautics and astronautics from MIT. He has worked on deep space missions at the Jet Propulsion Laboratory in Pasadena, California, and he co-founded the Planetary Society with Carl Sagan and Bruce Murray, serving as the organization's executive director for 30 years. He was co-leader of the Keck Institute for Space Studies Asteroid Retrieval Mission and Interstellar Medium Exploration Studies at Caltech. Here is Dr. Louis Friedman. In 1980, you co-founded the Planetary Society with Carl Sagan and Bruce Murray, and then served as its executive director for 30 years. Tell me about the Planetary Society. Why was it created, and what was its goal?
Well, Carl Sagan and Bruce Murray were struck by the enormous popularity which they lived with every day of planetary exploration. The Voyager mission was on its way to the outer planets. It made cover of Time magazines. The Viking mission had landed on Mars, and people were intrigued with the search for life in the solar system. And yet the government was making decisions to end planetary exploration, and I mean literally end it. And there was a total disconnect between the popularity and importance of the scientific exploration and the political will. So what do you do in situations like that? You form a public interest group to advocate for planetary exploration, and that's what we did. We saw a citizen's role involved. I'm a missions person, as my background at JPL indicates. I wanted to work on planetary missions. I had worked on Mariner, Venus, Mercury, and on Voyager and on Galileo, and I was looking forward to doing a great deal more, but the missions for the 1980s were all canceled. There weren't going to be any. And so we got together and we said, let's see if there's a role for private support, not for conducting deep space missions as much as supporting the government's role in continuing planetary exploration. And we were very successful at that. We grew very rapidly as a public membership organization. We turned around some of these decisions. We got planetary missions flying again. The Magellan mission was finally approved, and then the Mars program was finally restored.
What are some of the actions that were taken early in the Planetary Society's days, the efforts that were made?
Well, I think one thing that surprised all of us, that is Bruce and Carl and I and the others who played leadership roles in the society, was the importance of our own projects and internal funding to get things started. Not that we were going to conduct $100 million or $500 million missions, but that even $100,000 activities could seed further exploration. When the government got out of the SETI business, the search for extraterrestrial intelligence, we were able to fund the continuation of the search with the development of innovative receivers and placed at Harvard University, and we're able to continue on the SETI program. We funded some early studies in situ resource utilization for stimulating interest in Mars exploration. But as I look back on the Planetary Society, I think our two most influential and significant developments were basically getting the Mars program restored in the U.S. There wasn't any missions from Viking all the way to the mid-90s, and getting rovers installed in the program. Actually, the scientific community opposed rovers. They thought it took up valuable payload weight that could be used for instruments. And we saw a great deal of interest in that. And so we teamed with the Soviets and then later the Russians, who were actually developing Mars rovers. And it looked like they would do such missions if it was going to continue over there. And we brought a whole lot of attention to by conducting tests in both Russia and the United States. So that accomplished two purposes. One is it got a lot of interest in Mars exploration for the U.S. program, and the other is it brought the geopolitical power, just like the Apollo program had, to seeing that planetary exploration was a worldwide enterprise and that there were lots of opportunities and lots of things that it could be as an instrument of bringing people together to make greater accomplishments.
You wrote a book entitled Human Spaceflight, From Mars to the Stars. I thought it was available on Amazon. Apparently it's taking pre-orders. But if you would, talk a little about that.
Well, I got into solar sailing back when I was at JPL in mid-'70s to do a mission that couldn't be done any other way. That is to rendezvous and fly in formation with Halley's Comet. But it was a very audacious mission. I mean, even now it would probably be impossible. It was a huge sail, and it was for a heavy spacecraft, and it was as optimistic as we were that we could do it. It was still a project before its time. But the lure of solar sailing is almost anything you want to do in the solar system, you can do another way. But one thing solar sailing can do that you can't do any other way is it is the technology that can take us to the stars. And by that I mean it doesn't have to carry propellant. Now, when you get away from the sun, you need to have an external light source. You have to have beamed energy. And so the sun as a light source would be replaced by a laser as a light source. But that is the only practical means, and this has been verified in various studies and conferences over the years. It's the only practical technology we have now that we could see our way to developing interstellar flight. And that's a very special lure, because as we're learning now, especially with the great discoveries about exoplanets, there's no habitable world between Mars and the stars. Mars may not even be habitable, but it's barely so. And so if we think about the idea of moving civilizations or moving life off of this planet, it's basically from Mars to the stars. You have no other destination. And so the notion of whether or not we can fly interstellar is still a big open question. And so I got into that, and I went to some conferences, and I was disappointed because all of these conferences concentrated on technologies that I had been reading about since the 1940s. And I mean literally the 1940s and 1950s. Fusion, spacecraft, matter-antimatter rockets, cryogenically cooling people for multi-generation spaceships, huge kinds of arcs that would be flying in space for hundreds and hundreds of centuries and millennia. And the whole notion of life support, even in our own realistic programs, hadn't changed much. The kind of suits the astronauts were wearing in the 1960s and 70s are about the same kind of suits they're wearing now. The capability for flying long-duration missions is no longer now than it was in the days of Apollo. We're making progress. I'm very pleased with the NASA Journey to Mars campaign, but it's still, even if I project it out a century, it's still going to be a few years of space flight and missions that will be limited compared to the dimensions of the stars. And I realized that there's a whole set of other technologies that weren't getting adequate study, and that's very small spacecraft with solar sails that could exit the solar system very fast. And that made the whole notion of extending our human presence very different. We would extend our human presence not with our bodies out in space, but with the new technologies of microelectronics and nanotechnology and biomolecular engineering and advanced information processing and creations of virtual reality and virtual exploration. We would interact perhaps with other planets with pre-programmed biomolecule payloads on spacecraft and sending data back over huge distances to create virtual worlds for us to explore here. So that was sort of my changing notion of the future of extending human presence. But that led to the conundrum, which is, does that mean we're hidebound on Earth? Do we stay here only to be a single planet species with all the limitations of our eggs in one basket? And that is equally unsatisfying. And that of course, there Mars beckons, because Mars is a world that if we can't make it there, we clearly aren't going to make it anywhere else. And it does have the stuff of life support. It does have atmosphere. It does have water. So just for the reasons of creating another limitless goal for humanity of exploration, someday of settlement, Mars becomes not just the next destination beyond the moon, it becomes the only destination. We'll get to Mars. It'll take us thousands of years to do some things there, to settle it, to transform it. And by that point, we'll be all over the universe with our virtual exploration and robotic probes extending the human presence in that way. And that's what the book is about.
Before I forget, I want to congratulate you on having an asteroid named after you. If you would, tell me a little bit about maybe your reaction or maybe what you were doing when you got the news.
Well, it's very interesting. You asked about the Planetary Society earlier in our early project. We started funding several observers in the discovery of near-Earth objects before it was an approved program at NASA, before there was much even astronomy interest in them. In fact, some of the astronomers put down the whole notion of looking at asteroids as the vermin of the sky. They're just in the way. They're not interesting, and they're just tiny objects that clutter up the photos. Of course, we've learned a lot about NEO since then from a lot of points of view. The scientific point of view of how important they are to telling us about the origin and evolution of the solar system and the dynamics in the solar system, the existential threat to Earth by being hit by near-Earth objects as possibly a threat to the populations or even to civilization, and then the future possibility of exploiting them and using them for resources and conducting ventures deeper into space. But back in the 80s, we began helping astronomers who couldn't get funding otherwise. And one of them was a scientist by the name of Eleanor Helene, working at Caltech. And she had a program that was doing a first-rate job of discovering near-Earth objects, not by today's standards with the big NASA funding that's going into it, but by very limited citizen funding and small grants that could do it. And she very graciously named the asteroid for me and my wife. The official name is Louis and Connie Friedman. And we were, very honored. We got a plaque, we put it up in the office, and we have a bit of us orbiting somewhat eccentrically, I might say. But that's the way I feel I operate, too, out there in the solar system. Whether we, our descendants, ever get to visit it is not as important as knowing that a little bit of us is being remembered out there in space.
What are some of the ways that people can help the Planetary Society? And I'm thinking maybe people who are themselves not scientists.
Well, Planetary Society is a citizens group, and so you go to planetary.org, you can join the Planetary Society. They're conducting a mission now, which is LightSail, mission I started. We had attempted to do a solar sail mission first on a Russian rocket, which unfortunately ended up in the Arctic Ocean, so we never got to fly our spacecraft. And then we discovered through NASA another class of spacecraft, the nanosails. They also had a failed rocket, this American rocket, the Falcon, on its maiden flight, failed. And so they were looking to team with somebody, and we said we would do that. And as a result of that, we ended up building a somewhat more capable version of it. That is one with a communication system and an attitude control system. That became LightSail. And as you know, LightSail had a successful test flight. Now, it didn't do its solar sail mission yet, but it had a successful test flight of the boom deployment, which we designed. It can be a modest-sized sail. That's what's so nice about it. It was only 5.5 by 5.5 meters, which is still pretty big. It's as big as any room that you'll be meeting in the next few weeks. But compared to what we had for heavy spacecraft a generation ago, this one could carry a 5-kilogram spacecraft and achieve good accelerations to be able to accomplish a mission to increase the energy out of Earth orbit, or to fly out in interplanetary. They're now developing such things as for interplanetary CubeSats. JPL has picked up on the technology along with the NASA Marshall Space Flight Center, and they're going to be doing two missions in a few years. One is a lunar flashlight, which will reflect light on the moon, and one will rendezvous with an asteroid. So it led to this whole new class of spacecraft, which interests me so much for the future of interstellar travel, and that is very, very small spacecraft with sails that can build up big accelerations.
Excellent, excellent. I really appreciate you taking the time for the interview. It was excellent stuff.
Good, good. Well, I'm happy to do that, and I'm hoping that the kinds of discussions that come out of these meetings can lead to more creative ideas that bring things like LightSail and other good missions into being.
That was Dr. Louis Friedman. If you enjoyed this video, please click the like button, and you can subscribe to our channel for more such videos. I have been your host, Stephen Euin Cobb. On behalf of all of us here at the Tennessee Valley Interstellar Workshop, I thank you.